Okay, this video is going to take you through chapters 4 and 5 for your review for your midterm. So 4 was all about your triangles and 5 was your special segments that we just finished. We're going to start with 4. So 4.1 was all your transformations. Your reflection, your rotation, your translation, and your dilation. So here's a snapshot from 4.1 that goes through each of those. So you should be able to identify from either a graph or from the points shown what happens with X and Y, which of these is happening. The translation is the one where you add or subtract from your X and your Y. So that's your translation. The reflection is where you either put a negative on the X or a negative on the Y, but the X and the Y still stay in the same position. If you change the negative on the X, then it's a reflection across the Y-axis. You change the negative on the Y, then the reflection is across the X-axis. And then we had rotation. So the first two rotations, the X and the Y literally switch positions. The first one, they switch, but the X gets the negative, and that is a rotation 90 degrees clockwise. The second one, they switch, but the Y gets the negative. That's a rotation 90 degrees counterclockwise. And then the last one, they stay in their space, but they both get a negative or both get a change of sign. So that's where it's different from reflection. And this is a rotation of 180 degrees. And then the last one, which is the only one that changes the actual shape of it, is your dilation. And the dilation is where you would stretch your lines, either make them longer or shorter. So there's only one question from your packet about this, and that's where you're just identifying, it's number 31, it's where you're identifying which of the translations it is, or given the translation, figure out which of the graphs it would be. And then we got into 4.2, and 4.2 started your triangles. So this was classifying your triangles. So if you remember, there was two different ways to classify them, either by their angles or by their sides. So we'll start with the angles. By the angles, you've got acute, which is all less than 90 degrees. You've got right, which was one angle equal to 90 degrees. You've got obtuse, where one angle is greater than 90 degrees. And the last one, which is equiangular, which is all angles equal. And then the second way we classify is by sides. And for sides, there's only 3 of them. There's scalene, which is all different. No two sides are the same. There's isosceles, which has at least two sides the same. And the third one, equilateral, which is all three sides the same. So you've got a couple of questions on classifying triangles. Either they'll give you the measures of the angles, or they'll give you the measure of the sides, and you've got to classify it. .3 is where we learned a little bit more about the angles in the triangle. We started with the triangle sum theorem. Which said all the angles add up to 180 inside a triangle. And then we had the right triangle, where we found out that the two acute angles in a right triangle would be complementary. So if I had a right triangle and I had one of these angles, so like 30 degrees, I would know the other one would be 60 degrees because those two angles have to add up to 90 degrees. Then we had the third angles theorem. Which said if two angles of one triangle are equal to two angles of a second triangle, then the third angles must also be equal. So if I had two triangles and I knew that these were congruent, and then I knew that this angle was 30 degrees, then I can assume that this angle is 30 degrees by that third angles theorem. We also learned that all the angles in an equilateral triangle or equiangular triangle, because those would both be, would equal 60 degrees. So if the three angles are the same, then I know they have to add up to 180. They'd all be 60 degrees, and then each individual one would be 60 degrees. And the last relationship we learned about in this section was the exterior angle theorem. Which said that the exterior angle, so exterior angle equals the sum of the remote or non-adjacent interior angles. So in this case, angle 1 would equal angle 2 plus angle 3. And there's a couple of questions, again, from your, I'll mark them at the end when we get through all of chapter 4. So we spent for 4, 5, and 4, 6 talking about triangle congruence, and we learned about side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. And the good news is you don't need to know what these are like individually, but you do need to know like these would prove triangles are congruent. So these are the shortcuts that prove triangles are congruent. And then in 4.7, we learned about Cpctc, which we use after we prove the triangles are congruent. And you would use them to prove some other pair of relationships are congruent. So if I was given two congruent triangles, say this is A, B, C, and D, E, F, I would know that these two triangles are congruent because of side, side, side. And then I can use Cpct to say that angle A is congruent to angle D. Because if the triangles are congruent, then all of their corresponding parts are congruent. So that's the difference between side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, the 5 acronyms. Prove the triangles are congruent. And Cpctc takes it to the next step. If the triangles are congruent, then what else are congruent? So based on that, chapter 4, 4.1 has one problem in your packet, which is number 31. 4.2 has numbers 32, 33, 37, 47, and 48. 4.3 has numbers 38 and 49. And 4.7 has number 50. So the good news is all that's left is chapter 5, and chapter 5 should be relatively familiar because we just finished it. So chapter 5 was your angle bisectors and your perpendicular bisectors and your medians and your altitudes. So in 5.1, we talked about just angle bisectors and perpendicular bisectors, not necessarily inside a triangle. So we learned that an angle bisector obviously is a segment or a ray or a line that bisects an angle. But we learned the theorem about the angle bisectors, which said that any point along the angle bisector would be equidistant from the sides of the segment. So a point on the angle bisector is equidistant from the sides of the triangle. I'm sorry, of the angle. And then we learned about the perpendicular bisector. And this is a segment that intersects another segment. So it's a segment line array that intersects a segment at its midpoint and is perpendicular to that point. So it's perpendicular to a segment at its midpoint. And the theorem says that any point on the perpendicular bisector would be equidistant from the endpoints. So a point that lies on the perpendicular perpendicular bisector of a segment is equidistant from the endpoints of that segment. So you'll see a couple of questions based on that. You just need to know that they would be equidistant from the endpoints or equidistant from the sides if it was the angle bisectors. And then 5.2 is where we then put those same two segments. So angle bisectors and perpendicular bisectors. In a triangle. And this time we said that the angle bisectors meet at a point, which is the incenter, that is equidistant from the sides. So if I had angle bisectors, I'm going to kind of like eyeball where they would be, like maybe right there. And right there. And right there. These angle bisectors would meet at a point that would be equidistant from the sides. So from there to there to there. And all of them would have little perpendicular or little right angle marks. Those segments would all be congruent. And then the perpendicular bisectors, so the perpendicular bisectors meet at a point called the circumcenter. That is equidistant from the vertices. So again, if I had a triangle, and I'm going to try to eyeball my perpendicular bisectors, but they would be at the midpoint and they would be perpendicular. So something like that, something like that, and something like that. These would all meet at a point that's equidistant from the vertices. So from that point, which is the circumcenter, to each vertex would be congruent. And that was for 5.2. And then in 5.3, we got introduced into medians and altitudes, but you just need to worry about the medians. So the medians were the segments that connect. They go from the vertex to the midpoint of the other side. So if I identified where the midpoint was from each of these segments, they would look something like that. So this would be marked as congruent. This could be congruent to this, and this to this, and this to this. So it may not tell you it's the medians, but from the picture, you'd have to figure out that it's the medians. And the theorem we learned about that is the distance from the vertex to the point where the medians meet which is called the centroid, is 2/3 the length of the whole median. So if you got, if you were told something like this segment was 24 in length, and it wanted you to find, let's say this ABC, and it wanted you to find AB, AB would be 1/3 of that 24, so AB would be 8. And if it asked for BC, BC would be 2/3 of that 24, so 24 times 2/3. You can either divide by 3 and then multiply by 2, or multiply by 2 and divide by 3. Either way, you should get 16. So just be careful what it asks for, if it's asking for the 1/3 part or the whole thing. And that is it for the general concepts that are on your test. So there's a couple other questions that you'll find that are kind of application to a lot of this stuff. So you can use the time to work on chapter 4 and chapter 5. So from 5.1, you should be looking for numbers 39, 40, and 41. For 5.2, it would be number 42. And for 5.3, number 43.